Hello, Professor. My name is Moses. I'm going to make a presentation on Swat model for seasonal Kawalathe River in Turkana County. This is my watershed that I downloaded from the global watershed. The input data sources are as provided above with the links to the corresponding online sources. The steps in SWOT modeling are as displayed in the video herein. All the way up to SWOT simulation and visualization. So I'm going now to start opening QGIS and
So
the SWOT.
now this is the folder Kawalathe. I do delineation of the catchment and I load the DEM, which I was able to get from the USGS website. So I loaded the DEM. As you can see, the DEM is already loaded. So I go to the next step of creating the streams project. So the next step is to draw the inlet and outlet. For me, it is an outlet. So I select one of these points on the major river Kawalase, and just put the outlet there. I want to snap and see whether it is really on the river. You can see one object is snapped, so it is exactly at the river. Next is creation of watershed. It will take some time. As you can see, the watersheds have been created. So as we prepare to move to the next step, it is indicating that it is constructing the topology. So this is the final stage in the watershed delineation as we go to the next step of HRUs. So we are now in step number 2. As we can see, it is indicating that step number 1 of delineation is done. So we are moving into step number 2, which is creation of the HRUs. So we click on it and load land use data, soil data. You load the weather data, which is here loaded by importing. As we can see, that this watershed, the land use is rangeland. Uh, Basically, this is a pastoralist community where they do not have other forms of land use. So on the 4th stage of visualizing results, we are now visualizing quite a number of parameters that you can visualize, looking at the channel and coming to animated maps. So we look at the variable as one of the variables, which is flow out, and we can visualize on how it has been on the map. We can also look at other variables the, the other than the flow out. Can look at precipitation. As we can see, they are very well indicative. When you come to any other variable, you can look at maybe sediment storage. You see at the channel, they keep changing. So really, the model has been successfully. We see the simulation period is 45 years. The warm-up is 1 year. Weather is properly simulated. The watershed is about 275,000 hectares. 313 HRUs and LSUs are 315, 313 as well, and 33 subbasins. Checking on hydrology, uh, really, I see the average curve is 59.09. Out of 101 precipitation, we see that 92.95 is over 90% is lost through evaporation and transpiration. Indeed, it confirms what happens at these arid and semi-arid area. So we lose a lot of water through evaporation and transpiration. So looking at the sediments, maximum upland sediment yield of 0.01 and surface runoff of 8.53 millimeters per year, average upland sediments. So the details have really been properly brought. Plant growth, temperature, stress, days, everything here is zero. Land use summary. Thank you so much, Professor, for your time.